Hello everybody, I'm Hector Mejia working with Esteban Palomo, Ezequiel Lopez Rubio, Israel Pineda, and Rigoberto Fonseca. This is our project called Vehicle Speed Estimation using Computer Vision and Evolutionary Camera Calibration. First, we introduce the motivation. According to the Pan American Health Organization, approximately 3,700 people die on car crashes every day due to speeding drivers. And there exists an already infrastructure of surveillance cameras on most important cities and highways. Our proposed framework follows three components. First, the homography estimation, in which a certain scene contains a set of manually annotated point correspondences with world points and image points. This is the main focus of our presentation. We compared three methods for camera calibration. First, a basic algorithm using direct linear transformation. Second, a robust version using random sample consensus. And finally, our proposed methodology using estimation of distribution, which is an evolutionary algorithm. Then we have the object detection module using you only look once deep learning model. And finally, there's an object tracking component that assigns IDs to vehicles across frames using intersection over unit metric and also estimates speed for each vehicle independently. The proposed algorithm starts with the original set of world and image points. For the set of world points, we create the first generation by introducing random variation of each point using a predefined percentage. For each generated set, we compute the homography matrix using direct linear transformation. Furthermore, we calculate the errors using the original image point set and the estimated image point sets for each individual. Then, we keep k-generated world point sets using the least error. Next, we calculate mean and variance to breathe the next generation. This process repeats n times. Finally, the generated world point set with the least projection error is returned, and it is also used to compute the final homography matrix. Unfortunately, we could not find a dataset with addresses metadata to generate world points using Google Maps, nor they had speed annotations. Thus, 10 vehicles were recorded using the Seattle Department of Transportation portal, where each video had 25 frames per second, lengths with ranges from 8 to 10 minutes approximately, and variable resolutions. Finally, latitude and longitude and image point correspondences were manually annotated for each video. From the calibration results, we can see that both the basic and the random sample consensus algorithm behaves equally. However, the proposed algorithm accounts for an average of 97% reduction of the projection error, minimizing it on the first 5 videos. From videos 5 to 10, the projection error is null. In particular, these videos only contain 4 points placed at the corner of each region of interest, while the other videos have 7 to 8 points. On the right side of the slide, we can see a graphical comparison between the base and the proposed algorithm for video 4. There can be seen noticeable differences as the evolutionary calibration clearly reduced the projection error. As for the computed speed distributions, on the left picture we can see that in all videos the majority of the distributions fall below 100 km per hour, except for video 4, which had its 4th quartile with values close to 200 km per hour. More studies are needed to determine the factors that made the video 4 had the highest standard deviation. On the right image, we can see the time series for 10 different vehicles. They are characterized by soft curves that represent acceleration and deceleration, and no sudden spikes or abnormal behaviors are observed. If you want more information, here are the references. Feel free to ask any questions. Thank you.